Hey guys, so today we'll be doing a chemistry past paper, and it is the February-March 2024 paper 1, and the time is 1 hour 15 minutes. So let's begin. First question: which species contains the same number of neutrons as a carbon-14 atom and the same number of electrons as a sodium ion? So first let's find out the number of neutrons in the carbon-14. So the atomic number is given and the proton number is given. We know that the atomic number is the sum of the protons and neutrons. So to get the neutrons, we will just subtract 14 minus 6 and we should get 8 neutrons. I'm writing N for neutrons. So now we have to find out the number of electrons in this ion. So it's a positive ion. That means it has already one electron is removed from the initial sodium atom. So this number is the proton number, so we have to subtract 1 from the proton number, as 1 electron will be less than the proton, so it has 10 electrons. Now we have to match which amongst these have 8 neutrons and 10 electrons. So this one has 8 neutrons but 9 electrons. For the nitrogen ion, this one has 7 is the proton numbers, 16 is the atomic, so it has 9 neutrons, which is already wrong. And to look at the electrons, it does have 10 electrons. How? 7 plus 3, because it is gaining 3 electrons. For the neon atom, we can see it has 10 neutrons, which is already wrong, and also it has 10 electrons, but the neutron number is wrong, so these 3 are already wrong. It should be D, but let's see. So first up, atomic number is 16 for the oxygen ion, and it has 8 is the proton number. So neutrons is 16 minus 8, which is 8 neutron, and it already has like 8. The proton number is 8 and it receives 2 electrons, so 8 plus 2 is 10, so it has 10 electrons, which matches our initial thinking. Hence the answer is D. Question 2: which process has the largest enthalpy change per mole? So for this type of reactions, what type of reactions are these? These are the ionization energy reactions. So for this type of reactions, the more number of protons, right, or like more number of charges, we can also write charges, the more attraction with nucleus and outer electron, and for that reason more energy is needed. This means that the enthalpy change is more. So in all these reactions, the highest number or the highest charge is this one, where the sulfur ion changes from a charge of +6 to +7, and this is the highest. As you can see, in all this is from +3 to +4, this from +5 to +6, and this is from +4 to +5. So answer should be C, as it has the highest charge or proton number. Question 3: which sodium compound contains 74.2% by mass sodium? So we have to trial and error for each of them. So let's write the formula. So sodium carbonate is Na2CO3, sodium chloride is NaCl, sodium hydroxide is NaOH, and sodium oxide is Na2O. So the sodium ion was plus, so that's the valency is plus. Okay, so now we have to calculate. So for sodium, the MR or the AR for sodium is 23. So in this one, the first one, we are going to trial error the first one. It is 23 into 2. I have to see there are 2 sodium atoms, so 23 into 2, and the total MR of this, which is 23 into 2 plus carbon is 12 and oxygen is 16, so 12 plus 16 into 3, this should be, and multiply the entire thing by 100, so Let's see what we get the answer to be. This is 43.4%. So I will just do this exact same type of calculation for part B and C. I'm just going to write the percentages beside since I'm running out of space. 23 by 23 plus. For chlorine, the AR is a 35.5, Cl is a 35.5, so 35.5 into 100. This one is 39.32%. For sodium hydroxide, the thing is, so hydrogen is 1 and oxygen we've mentioned. 23 by 23 plus 16 plus 1, it gives 57.5%. so it should be D since all these are wrong, but we'll check. For this it is, again we have two molecules, so it should be 23 into 2, 23 into 2 by 23 into 2 plus 16 into 100%, which, yes, this gives us 74.2%. use this exact calculation and see if you get the answer. If there are any confusions, definitely comment down below. So number 4, what is the maximum volume of sulfur dioxide gas measured at room conditions produced from burning 100 dm³ of diesel fuel containing sulfur? So since it's burning, the reaction is with oxygen, so the reaction is kind of this way, SO2. It's balanced, so you don't have to balance. So we have been given the mass of sulfur and we need to see the volume of sulfur dioxide formed. So we will use this to get the mole of sulfur, which is 0.8346, the mass by the MR or AR. So for sulfur it is 32.1. let's use the calculator. Divide 32.1. this is 0.026 moles, and finally we'll just multiply this by 24,000, which is actually 24 dm³, but since the answers they're asking in centimeter cubes, so we'll just multiply the number of moles with the 24,000 cm³, and the answer comes in my calculator to be 624 cm³. so what I can see, the answer is D. So let's move on. Question 5. Which row shows the correct number of covalent bonds in a molecule of methyl propene? So methyl, this is a methyl propene. Another carbon there. The hydrogens, which are all single bonds. Okay, so the total number of sigma bonds in the molecule, total number of pi bonds in the molecule. So single bonds are always the sigma bond. Double bonds have one sigma bond, one pi bond. So just let's calculate the sigma bond. This is a sigma bond, this is a sigma bond, another sigma bond, another sigma bond, and this is another sigma bond, this is a sigma bond, another sigma bond, this is the first and only pi bond, sigma bond, and then a sigma bond, another sigma bond. So the answer will be amongst answer A and C because there is only one pi bond. Number sigma 1, 2, 3, 4, 5, 6, 7, 8, 9. 1 minute. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So just a small mistake. So here, since there are already a double bond here, so this carbon only has one and two hands open, and for that reason there are only 11 sigma bonds and one pi bond, and we will have answer to be C. Just this right, that is D. So I just now written the hydrogens. They're all just hydrogens over here. You can, yeah, you guys of course know they're all hydrogens here. Okay, so that is that one. We'll move to question 6. Aluminium chloride exists as Al2Cl6 molecules at RTP. When heated to a high temperature, AlCl3 molecules are formed. Okay. What are the arrangements of the bonding pairs of electrons around the aluminium atom in the two forms of aluminium chloride? So first let's draw Al2Cl6. I think you people already know the structure. You have to know the structure of how to draw a aluminium Al2Cl6. So, oh sorry, what am I even doing? 1 minute. So it is Al, so there is one Cl molecule there, the other Cl molecule is there. Man, this is so not okay. Okay, Al, so Al and Al, then you'll have like a Cl over there. That is one Cl, and one more should be over there, Cl, then a Cl over there, another Cl over there. Please forgive my drawing. That's another Cl. So around each aluminium we can see there are 1, 2, 3, 4. So there are like 4 bond pairs and no lone pairs. So this one has 4 bond pairs, and we know that that structure is called tetrahedral. So answer has to be between this, as it has to be tetrahedral. And for AlCl3, the structure is 1 aluminium and just 3 Cl. This is the aluminium and 3 chlorines. So here we can see that there are 3 bond pairs. So this one has 3 bond pairs, which is a trigonal planar, or yeah, planar. So answer should be B. We'll move on to question 7. The table shows the physical properties of 4 substances. Which substance has a giant covalent structure? So for a giant covalent structure, the first thing is the electrical conductivity is like there is no electrical conductivity, or it is very low in both solid and liquid forms, and its electrical conductivity in aqueous solution is also poor, or there is no electrical conductivity. But since it's a giant structure, the melting and boiling points will be quite high, and this is just all the theoretical knowledge I'm talking about. So we'll first take the melting boiling point. Okay, so these are very low. Okay, these are very high. So A and B are wrong. And as I told, the conductivity is poor for solid state. It is okay. So this is written good. This is wrong. It is poor in any state, and yes, insoluble, or it is also poor in aqueous state. So answer should be D. And also the melting and boiling points are very high. You have to of course choose the higher values. So that is question 7. Sorry. Okay, question 8. At RTP and pressure, H2 is a liquid and H2S is a gas. What is the reason for this difference of state? So in liquid, the intermolecular forces are very strong compared to a gas, where if this is a liquid molecule, a very close, of course not arranged, but very close, and in a gas this could be the structure very far apart and of course not arranged again. So this is for liquid, this is for gas. And what is the reason behind it? So we know that the hydrogen bonding, hydrogen bond is the strongest intermolecular force. I'm just writing IMF, intermolecular force. So the options should definitely be something related to the intermolecular force and also related to hydrogen bonding. And yes, so let's look at the option. O has a higher first and second ionization energies than S. That is not the reason for this difference. The covalent bond between O and H is stronger. No, it does not have any covalent bonds. It's completely intermolecular forces. There is significant hydrogen bonding. Let's read bonding between H2O molecules, but not between H2S. So for hydrogen bonding, we know that the F, fluorine, oxygen, and nitrogen. These are the atoms that need to be present in one of the molecules, and the other molecule needs to have a lone pair, and that is only when the bond will form. And for that reason, I will keep C as an option. The ID forces between H2O molecules are stronger. Is the ID forces between H2S, but that is wrong because if you look at the periodic table, let's see the number of electrons in H2O. 2 hydrogen molecules, so 2 electrons there, and oxygen has 8 electrons, so 10 electrons for H2O, and for H2S again 2 plus 16. So the ID force depends on the number of electrons, and H2S has more electrons. So that is not the explanation, so that is wrong as well, and answer should hence be C. Right. Question 9. The enthalpy change for a reaction that can be calculated from values of enthalpy of formation del HF, enthalpies of combustion del HC, and bond energies as well. The enthalpy change of the reaction given equal to del HR at standard conditions, and this is the equation given to us. Which expression could be used to calculate del HR? So if we use the del HF values, then it is product minus reactant, right? Whatever I just written, reactant minus product. It is the reactant minus product, and it could be the del H formation of ethane and the del H formation of methane. So we'll just subtract the, and also have to multiply by 2 to the del H value. So let's see which option has that. Only the del H combustion of ethane is not going to really work. This is what I was talking about, this equation. The del H formation of the reactant minus the product and multiplied by 2. And one minute. That's wrong actually. One thing, like the option is correct, but the thing is they have used del H of combustion. I have been saying formation, but actually they have used del H of combustion, so that is what we will use as well. Combustion and reactant minus product is okay. For del H formation, that is product minus reactant. That is what arose to my confusion. So B should be the answer. Let's look at this. Del HF or CH4. Okay, so whilst using the del HF formation, we only use elements under standard conditions. We do not use water or carbon dioxide compounds, so those cannot be used for del HF. And since our option D has used del HF, I will have to eliminate that option. And okay, so using the bond energy actually, there are lots of things they missed in this equation of reactant minus product, so hence that is wrong. Answer should be B. So number 10, which reaction has an enthalpy change equal to the standard enthalpy change of formation of propane? So we know that for formation it is the production of 1 mole of compound from elements, and it's under standard conditions. And by that logic, but first look, are all of them 1 mole or not? I can see that they're all 1 mole, and Okay, actually, so first we can directly choose an option of D here. Why? Because the compound that will be formed will also be under standard conditions, and C3H8, which is propane, is a liquid, right? Under RTP, it is a liquid, and all of these are gas, right? And we'll also check some more things. Carbon is a solid, like we know about graphite. So carbon is a solid in room conditions, and hydrogen is a gas. That's fine. But here, so answer, if you made an elimination on the state of carbon, A and B would have been wrong. If you directly go in the elimination of the state of the product, that is propane, you would see that propane is a liquid. And this is again all about the theoretical concepts we have been using. So that is question number 10.